Hi there. This lesson covers section 4.2 in Math 114a, and here we're going to talk about graphing linear equations of two variables when that linear equation is expressed in a standard form. So our objectives for this particular lesson are, first, to graph linear equations on the Cartesian plane. Finally, we're going to talk about, we're going to do this first. We're going to talk about the linear equation in its standard form. And then finally, we are going to talk about finding the x and y intercept of an equation and use those intercepts to graph that equation. Okay, well, let's first talk about the standard form of a linear equation. It is going to be represented as some real number times our independent variable x plus some other real number times our dependent variable y, which will be equal to yet another real number, which we will call c. Yes, a, b, and c are real numbers. X is our independent variable, and y is typically our dependent variable. And the only requirement we have is that both a and b cannot be equal to 0. Because if they are, well, then we have 0 is equal to c, which means that c is 0, and there's really not that much to do. A can be 0, or b can be 0, but they cannot both be 0. Now we want to talk about graphing linear equations. And the thing we need to know about linear equations is, well, they result in a straight line. As a consequence, the only thing you need are 2 points. Once you have those 2 points, you have everything you need to graph that equation. So we are going to determine 2 points. But we're going to choose these points in such a way that computing them is a piece of cake. We're not going to choose crazy points or whacked out fractions. Chances are we're going to let one point be 0, and then we're going to use that information to figure out what the other value is. In other words, we're going to let one coordinate, such as the x-coordinate, be 0 and solve for y. And then we might let the y-coordinate be 0 and then solve for x if we can and see what happens. Once you've done that, we are going to plot those 2 points on the plane. After we plot those 2 points on the plane, we are going to, yes, connect the dots. And that's going to give us a straight line all through the plane. And then finally, we are going to check. How are we going to check? Well, we're going to plot a third order pair that satisfies the equation and see if it falls on the line. If it falls on the line, we did our job. If it did not, there's a mistake somewhere, and we need to figure that out. Okay, so let's get started with an example. And here we are going to graph this equation. 2 times x plus 3 times y is equal to 6. Notice that this is in standard form. All right, so we're going to determine our 2 points. How are we going to do that? Well, how about if we just go ahead and let x be equal to 0? Then we can solve for y. And we will have 2 times 0 plus 3y is equal to 6. Fortunately, 2 times 0 is 0, which means we're left with 3y is equal to 6. We can divide both sides by 3. These cancel. We're left with y. 3 divided by 6 is 2. So we have when x is equal to 0, y is equal to 2. And that means that the ordered pair 0, 2 will satisfy this, is a solution to this equation. All right, so there's 1 point. We need to find another point. How about if we find that point by letting y equal to 0? Okay, in that case, we will have 2 times x plus 3 times 0 is equal to 6. Okay, well, 3 times 0 is 0. That's kind of convenient. That means that we're left with 2x is equal to 6. We can divide both sides by 2. And we have that x is equal to 3. So when y is 0, x is 3, and the associated ordered pair is going to be 3, 0. And now we can go and plot those values. What are we going to plot? We are going to plot 0, 2, 0, 1, 2. That's right there. And then we are going to plot 3, 0. 1, 2, 3. You don't need to go anywhere. Right there. And there they are. Now notice that 0, 2 is sitting on the y-axis. It is touching the y-axis. As a consequence, we call that the y-intercept. And notice that we compute the y-intercept by letting x be by forcing x being equal to be equal to 0. And when we do, we are somewhere along the y-axis. Once we let x being equal to 0, we just solve for y and we find our intercept. And notice how this point 3 comma 0 is sitting on the x-axis. As a consequence, this is called the x-intercept. And we find the x-intercept by setting y equal to 0. That puts us on the x-axis, and then we can solve for x. Once we have plotted those 2 points, step number 3 is to connect the dots. And there we go, we have connected the dots. Better PowerPoint do this than me trying to do it by hand. And this is hopefully the graph of our linear equation. Step number 4 is to check. Now when we check, we still want to find a point on this line which is easy to compute. And notice here that this line is crossing, that this line crosses the point where x is equal to 6 and y is equal to -2. All right, so let's, how about we let x be equal to 6 and see what we get for y. Well, if x is equal to 6, we have 2 times 6, which is 12, plus 3y is equal to 6. We can subtract 12 from both sides. If we do, this cancels. We have 3y is equal to -6. We can divide 3 by both sides. And if we do, we will have y is equal to -2, which gives us 6 comma -2, which is this point right here, right on the line. So it works out, and we have good confidence that this line represents the equation. All right, let's do one more example. All right, this still should be example 2. Okay, now we're going to graph x minus 2y is equal to 1. Notice that this is still in standard form. And how are we going to do this? Well, we're going to determine 2 points, the exact same way we did it before. We are going to let x be equal to 0, and we are going to find y, which also means we're also going to try to find the y-intercept. So if x is equal to 0, that means we have 0 minus 2y is equal to 1. I can divide, and that's just the same as minus 2y is equal to 1. I can divide both sides by -2. And I will have y is equal to -1/2, which gives us the ordered pair 0, comma, -1/2, which is the solution to this equation. Okay, great. Now let's let y be equal to 0. And this is why we like to let things be equal to 0. Then we have x minus 2y. Well, since y is equal to 0, that's x minus 2 times 0 is equal to 1, which implies that x is equal to 1. So in this case, our ordered pair is 1, comma, 0. And those are the 2 ordered pairs that we need to plot, which we will do on the next slide. Okay, well, here is 0, comma, -1/2. It's right there. And then 1, comma, 0 is right there, as we can see by those. Oh, that did too much at the same time. As we can see right there. And if we connect the dots, here is our line, and then we need to check. Now the way we can check is, once again, try to find a point where the line is crossing both grid lines. For example, right here it's crossing at x is equal to 3 and y is equal to 1. So let's let x equal to 3 and see if we actually get y equals to 1. Well, 3 minus 2y is equal to 1. We can subtract 3 from both sides. These cancel. We will have -2y is equal to 1 minus 3, or -2. We can divide both sides by -2, and we get that y is equal to 1, and that corresponds to the ordered pair of 3, comma 1, which is this point right here, which falls right on the line, so we know we are good to go. Also notice that, once again, this point right here, 0, -1/2, is on the y-axis. This is the y-intercept. And we found that by setting x equal to 0 and solving for y. This point right here, 1, comma, 0, is the x-intercept. And we found that by setting y equal to 0 and solving for x. And that brings us to our very next topic, locating the x and y intercept. And you'll never guess how we do it. Yes, you are right. To find the y-intercept, we need to get onto the y-axis, and we do that by letting x equal to 0. And then when we solve for y, we can figure out where that line is going to cross the y-axis, and we call that the y-intercept. Similarly, to find the x-intercept, we have to get on the x-axis, and we do that by letting y being equal to 0. And then we solve for x, and when we do, we will find that point where the line crosses the x-axis, and that is called the x-intercept. And so let's work a couple of examples where we need to do that. You're going to be asked a couple of problems where you're going to be given an equation in standard form, and you need to find the x-intercept, the y-intercept, and then use those 2 points to graph an equation, or at least to place those 2 points on the Cartesian plane, and then Hawks will graph the equation for you. So here we have x plus 3y is equal to 9. To find the x-intercept, we want to let y be equal to 0. Now we'll give us x is equal to, no, it's going to give us x plus 3 times 0 is equal to 9. Well, 3 times 0 is 0. So we can rewrite this as x is equal to 9. And there we are. Our x-intercept is going to be 9, 0. Okay, what about our y-intercept? Well, for that one, we are going to let x equal to 0 and solve for y. That will be 0 plus 3y is equal to 9, which is 3y is equal to 9. We will divide both sides by 3. These cancel, and we have y is equal to 3. And the associated ordered pair is, well, x is 0. Y is comma to 3. This is the y-intercept, and this is the x-intercept. Now we need to plot them. Okay, well, here is our Cartesian plane, and 0, 3 is right here. That's our y-intercept. 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right there. So there they are plotted. And now we just need to connect the dots. And there you are. And we have successfully completed example 3. We are going to do one more example before we move on over to Hawks. Okay, and this one is the equation in standard form 3x minus 2y is equal to 12. To find the x-intercept, once again, we're going to let y equal to 0. So x. When we do, we will have 3x minus 2 times 0 is equal to 12. And 2 times 0 is 0, so this is nothing more than 3x is equal to 12. We can divide both sides by 3. And these will cancel. We will have x is equal to 4. And the ordered pair associated with the x-intercept will be 4, 0. To find the y-intercept, we will let x equal to 0, and then we will solve for y. So that will give me 3 times 0 minus 2y is equal to 12. Okay, well, 3 times 0 is 0. So that means we just have minus 2y is equal to 12. We can get rid of the, we can isolate y by dividing out the coefficient minus 2. So divide minus 2 here. Divide minus 2 here. These cancel, and we have y is equal to 12 divided by negative 2, which is negative 6. So the ordered pair associated with the with the y-intercept is going to be 0, negative 6. And now we just need to plot those. Okay. Well, 4, 0 is 1, 2, 3, 4 right here. 0, negative 6, we start at the origin, we go down 6 units. 1, 2, 3, 4, 5, 6 is right there. So there we are, we have plotted those points. And now all we need to do is connect the dots. And there we are. And that is pretty much the things that you will need to do for this particular lesson. Now, let's go over to Hawks and let's actually practice a couple of problems so we can see how this thing works in the interface. Okay, so here I am at my dashboard. We are at lesson 4.2, graphing linear equations by plotting points, and I'm going to go ahead and practice to pre-certify. And there are basically two different types of problems here in this lesson. And this is the first type. Okay, we have, oh, hang on a second, there's something else I wanted to do. Okay, I forgot to bring OneNote up, but it's up now. So we have the equation negative 5x plus 5y is equal to 0. That's not a very fair equation, but let's take a look at it. All right, negative 5x plus 5y is equal to 0. We want to enter two coordinates to plot on the graph, and once we've done that, a line will be drawn for us. So we actually want to come up with 2 points that satisfy this equation. So let's let x be equal to 0. Well, if we do, then we're going to have negative 5 times 0 is plus 5y is equal to 0. Well, that's not fair. This cancels. We have 5y is equal to 0. We can divide both sides by 5. And we have that y is equal to 0, which corresponds to the ordered pair 0, 0, which goes straight through the origin. Okay, awesome. So we can come over here and we can type in, there we go, we can type in 0 here and 0 here. And there's our point right down there. There's our first point. Okay, now in our examples, I would say, well, let's let y equal to 0 and see what we get for x. Well, if we did, we're just going to get x equals 0 again, which is the exact same point. So we need to come up with a different value. So I'm going to suggest, well, how about if we let x be equal to 5? And you'll see why in just a second. Let's let x be equal to 5. In that case, we're going to have negative 5 times 5 plus 5y is equal to 0. All right? Well, negative 5 times 5 is negative 25. Plus 5y is equal to 0. I can add 25 to both sides of the equation. When I do, these will cancel, and I have 5y is equal to positive 25. And I hope now you understand why I chose x is equal to 5. All right, so now I can divide both sides by 5 to get rid of the coefficient. These cancel, and I will have y is equal to 5. And my associated ordered pair is going to be 5, 5. So I can come over here to Hawks. I can put a 5 in here. I can put a 5 in here. If I wanted to, I could do another line just to see what I get. And then, actually I could have done x is equal to 1. And then I can submit and see if I'm right. And there we go, we got it correct. Okay, so let's move on to another problem. As you can see, they are all the same. They are all similar. This one is still not, this one, well, let's go ahead and do this one. We have y is equal to x. All right, well, y is equal to x. That's not necessarily in standard form, but we can still work with it. Let's let y be equal to 0. Well, then obviously x is equal to 0. So we put a 0 here, and we put a 0 here. Okay, well, how about we let y equal to 1? Well, then we have 1 is equal to x. And that, of course, is 1, 1. We can put a 1 here, and then a 1 here, and submit, and we should be correct. Yay me. Okay, let's take a look at this problem. This problem is a little different than the ones that we've talked about, at least in the slides. And so we probably want to address this a little bit. Here we have y is equal to 3/2 x minus 8. Okay, now again we want to find 2 points. Of course, first we might want to let x be equal to 0. If we do, we have y is equal to 3/2 times 0 minus 8, which means this cancels. 3/2 times 0 is just 0. So we have y is equal to minus 8, and our ordered pair is going to be 0, minus 8. And we can go ahead and put that in. Now for the second point, and there's our point. Now for the second point, I would ordinarily recommend that you just let y be equal to 0 and solve for 3/2. But in this case, I think it might be better if we let x be equal to 2. It's okay if we just find another value for x instead of 0. Because if we have that, then we're going to have y is equal to 3/2 times x, which by the way is 2, minus 8. The 2's cancel. See that right there? This 2 will cancel this 2. And we will have y is equal to 3 minus 8, which is -5. So now our intercept, or I'm sorry, our second point, although it's not an intercept, is going to be 2 comma minus 5. And if we put that in, we have that point. Let's see, there's 2 minus 5. And then we can submit, and there we have our answer. And it turns out right. So let's move on. Here we want to graph the line by plotting any two ordered pairs with integer value coordinates that satisfy this equation. Okay, so we need to find ordered pairs that are integers. Well, let's start off. So here we have -2x minus y is equal to 0. Okay, well, let's let x be equal to 0. If we let x be equal to 0, we will have that minus y is equal to 0, and of course y is equal to 0. So we have our ordered pair 0, 0. And what does that tell us? Well, that basically means that we really can't set y equals 0 because we'll get the exact same pair. So how about if we set x equal to 1? Okay, well, if we set x equal to 1, then we will have -2 times 1 minus y is equal to 0. We can actually add positive y to both sides, and we will get -2, these cancel, is equal to y, which gives us the coordinate pair, the ordered pair 1, -2. So we can plot 1, -2, 1, -2, and there we are. Is that correct? Let's submit our answer, and it turns out it is. For this one, we have the equation -4x plus 10y is equal to 40. All right, to find the y-intercept, we need to let x be equal to 0. In that case, we will have -4 times 0 plus 10y is equal to 40. -4 times 0 is just 0. So we have 10y is equal to 40. I can divide both sides by 10. And then we'll have that y is equal to 4. So our ordered pair for the y-intercept will be 0, 4. Okay, and there it is. Now for the x-intercept, we will let y be equal to 0. And that will give us -4x plus 10 times 0 is equal to 40. Of course, that's just nothing. This is 0 right here, so we just this -4x is equal to 40. I can divide both sides by -4. And I will have that x is equal to -10. So our ordered pair is going to be -10, 0, and this should be our x-intercept. -10, 0, and submit our answer, and yes, we did it correctly. And let's just do one more problem. And this one we have -10x minus 6y is equal to 30. Okay, so let's let let's find the y-intercept. We'll let x be equal to 0. We will get -10 times 0 minus 6y, that's supposed to be times, is equal to 30. That, of course, this is 0, so we have minus 6y is equal to 30. We can divide both sides by -6. and we will have y is equal to 30 divided by -6, which is -5. And the ordered pair is going to be 0, -5. There we go. Okay, next for the x-intercept, you want y to be equal to 0. Oh, hang on a second. That should be a positive 10x. That makes that a positive. Oh, no. We're fine. We're fine. It's still -5. Okay, but that should be a positive 10x. That was a mistake. So in that case, we're going to have y equals 0. So we're going to have 10x minus 6 times 0 is equal to 30. That will be, this cancels this, that's 0. So we have 10x is equal to 30. We can divide both sides by 10. And we will have x is equal to 3. Once again, the equation is positive 10x. I kind of made a mistake here, but since I was multiplied by 0, it didn't particularly matter. And here our ordered pair for this equation is going to be 3, 0. And let's put this in here and see what we get. 3, 0. Submit the answer. And it works out. And all the equations are, and the rest of them are pretty much just like that. So that is all I have for this particular talk. If you have any questions, please feel free to contact me. And this is Bob Boyle signing off.